see that we first connect the sensor to the laptop, and then it will showing that it's the USB several device. It's COM5, so it's already COM5. I just click connect, and it's just showing that it's connected. In app, I can have a lot of functions like we can figure out figure out the units, and also we can plot either the temperature or the humidity. And this part is the indicator that showing the real-time temperature, also the humidity. And this one is the status lab. If I running it, it will become green. And these two parts is well the temperature and humidity indicator. If I set a volume that the real temperature is above the volume that I set, it will become red, and otherwise it will become green. And this is the kinetics window. So let's start now. I can just set up like 40, and the humidity is 50, and I can start now. So it's just showing the graphing, and here is the kinetics. It has some max, min, and standard deviation. And now, if I hold the sensor, you will see the result. You see the temperature, both the temperature and the humidity will increase, and it's increased very large, and it's about 50. Is bigger than the 50, so the indicator will become red, and the temperature is also changed very large. And then I just release my hand, and the volume will be decreased, will be also decreased like this. When it's back to 50, the light will become green. So I can just stop now. So the status is red, and in the last part, our product can save the data and load the data. We can save the data, and here is we can choose the location that we want to save. We can choose the name and location. Like we just have a file name that name the output, and we save, replace it, and then it's all that. So this time I do not want to use the sensor. I just want to show the data that I saved. I just click load data, and there's the output file, and there is the result of the result of the last tab, and also there have some kinetics of the last tab. The first things that will be the function. It will execute the function called UI disconnected. So it will disable most of the components inside the main program, like the secret box and the input box. And the only two things that is activated is the connectors and the data loader. And so we need to connect it. Like the connector is at this time the one is COM3. So I just input the COM3, and when I click the connect, it will execute this function called several connect, and it's used to configure the connectors, the several connectors, and if it is connected successfully, it will output a message bar called connected. Also, if it's failed, it will output an arrow called failed arrow. So this time I will click the start. So when I click the start button, it will execute the function called start, and it will receive the data from the sensor, and then plot it on the and use these two sentence set to plot it on the program on the main box. So and last time if I click stop, it will jump to the stop function, and it will disable most of the part and config and generate the output and also the light.
So this code, this sentence of code is for the statistics part. I created a table right here, the UI table. It has the name of the max, mean, standard deviation, and those functions building. I put those building functions there. So it's just this one sentence to put in the statistics in the table. And I also did the file save and file loading part. So file saving part can save the two matrices, the M and T, into a file using the building function called read matrix. And the selected file can be also loaded using the read matrix function. And so like the selected file will be converted to a matrix which contains 3 lines, which are the time, the temperature, and the humidity. So this data can be plotted using the plot function, and the statics of the function will be processed again as so that part of the data shown here. So like the user could click the save data, and that will activate the saving file function, and load data, which will activate the loading file function.
This is the temperature gauge and the humidity gauge, and they take the input from the Arduino, so the raw temperature and the raw humidity. They take those, and the value will change if the input changes on the Arduino. Also connected to that are the temperature indicator and the humidity indicator. Input a value here, so let's say you put like 50, and if the temperature is greater than 50, then this will change. The color of the indicator will change. And same for the humidity. So if this reaches like above the threshold that you set, like if the humidity is greater than the threshold that you set, then this will change color. So like, this is the code. Like this shows the gauges and stuff. So this is obviously just set to the raw temperature and the raw humidity, which is collected by the Arduino. And then these are the codes for the indicators right here. So obviously you can see that the color is set to change whenever it reaches a certain value. And so since it's less, it will go to this code. If it becomes more, then it'll become this code, which turns the indicator. So another thing that we did was that we took the raw data, like the raw graph, and then we used splines to smooth the data to create a nicer curve. So here you can see how it's become smoother, like using the splines to create that more smooth line instead of the kind of bumpy line that you would get from having just the raw data graphed. So you can see here, we basically took the data and we added more data points to it so that it wasn't so jumpy, like there wasn't such a big gap in between data points. So adding the data points using the spline basically creates that smoothness that the original graph lacked.